Hello everyone, my name is Brian Solvay and I manage sales in the Rocky Mountain region for 1Spatial, based out of our Frederick, Colorado office north of Denver. I'm joined today by Melissa Ubaldo, one of our talented solution engineers. Melissa is based in our U.S. headquarters office in Indiana, Virginia. I want to thank everyone for joining us today to talk about the challenges with geospatial data. Today, we'd like to focus on some work we've been doing with a variety of organizations across different industries. We're helping them navigate how they handle the constant changes of the data coming in and dealing with the persistent requirements on that data and help them improve those management processes. There must be a reason why this presentation attracted your attention, so I want to begin with a quick data quality checkup and encourage everyone to think about data quality and data quality management in your respective departments or organizations throughout this presentation. What is the desired state of your data? Think about where you need your data to be in terms of business requirements that need to be met, the purpose of the data, and the level of quality your data must be in to fulfill that particular purpose. And then think about where you currently stand with your data. Is it meeting the requirements to serve its purpose? If it does, are you able to measure that quality by which it serves? I ask you to please think about these data quality issues as we go through the presentation today. For those of you who aren't familiar with us, 1Spatial Inc. is a U.S. company that's a wholly owned subsidiary of 1Spatial Group in the U.K. The organization began its life over 50 years ago at Cambridge Labs at Cambridge University. Cambridge still serves as the organization's worldwide headquarters today. Our U.S. headquarters is located in Vienna, Virginia, with satellite and sales consulting offices across the U.S. Additionally, there are 1Spatial offices around the world, all providing local support and technology implementation for our growing global cluster list. We have significant experience across a number of industries, including federal, state, and local government, transportation and infrastructure, utilities, both electrical distribution and water, and within the facility management segment. One of the keys to our success is a solid technology partnering approach. So the 1Spatial team on a global level has significant experience in ancillary technologies that are key to our joint success. Several of those key partners are listed here. As I mentioned, 1Spatial has 50 years experience developing data management solutions. However, in the U.S., we started about 7 years ago, with our first customer being the U.S. Census Bureau. Listed here are many of the other customers that have come on since that time. Many of our projects with these customers are supporting them with our rule-based approach to conflate, validate, and integrate their data. This data could be focused on addresses, next-gen 911, transportation data, utilities, as well as spatial data infrastructure projects. Some of the organizations we have worked with include the state of Nebraska, where we're working with the state on automating their processes for taking data from CAMA, or computer mass appraisal systems, and validating the incoming data and integrating it within their overall state GIS. We're also working with organizations to help them with facility management applications. So organizations like Google's Real Estate Worldwide Services group are leveraging 1Spatial's tools and services to implement validation of their CAD drawings to assist in easy ingest into their IBM Tririga asset management system. 1Spatial is currently working with the state of Michigan on a spatial data infrastructure project known as the Michigan Geographic Framework, or MGF. The existing spatial data infrastructure contains statewide layers for parcels, address points, road center lines, and other administrative boundaries that add an additional about 100 plus layers. These data sources are all stitched together to be one cohesive data source that is available on a data portal being served out by Esri's ArcGIS Enterprise. To build a statewide spatial data infrastructure, the state really must rely upon the data stewards from organizations across state and federal partners, as well as cities and counties and third-party data suppliers. 1Spatial has implemented our OneIntegrate product to automate the validation, change detection, and integration of all these data sources into the MGF. Data suppliers submit their data via an online data portal. The data then goes through an initial set of validation checks to make sure the data meets the business requirements of MGF. The data then goes through a series of change detection checks to flag if data has changed between what is already in the MGF and what is being submitted. Changes are then coded with the type of change. So it could be an add, a deletion, a spatial update, attribute changes, or a combination of spatial and attribute changes. Those changes can then be reviewed and accepted. Next, those changes are applied into the database. Some additional automated processes are performed, for example, splitting roadways at boundaries and generating intersection points. Lastly, The integrated data goes through a larger validation process to determine if there are any downstream anomalies with that data. This process enables the state of Michigan to maintain a statewide spatial data infrastructure that can be leveraged to statewide partners. I would now like to hand it over to Melissa for a brief overview of the 1Spatial technology and a product demonstration. Melissa, it's yours.
Thank you, Brian. Before we jump into the live demo, I'd like to briefly go over the capabilities that our solutions revolve around. I first want to talk about the steps that we actually take with our customers towards implementing a more effective data quality management methodology. Our approach here at 1Spatial is all about writing rules. We want to create automated data management workflows out of your business rules using our highly configurable rules engine that we call 1Integrate. Data validation is the simplest way to establish that baseline set of standards that you want to require your data to meet. By writing out your business rules, you can create data validation workflows that find anything that fails those rules. If your data for some reason could use a bit of help to meet your rule standards, you can leverage the quality by writing rules that would integrate it with other sources. The rules engine enables you to connect across the entire enterprise and actually tap into spatial and non-spatial data sources, as Brian has mentioned. This is especially helpful if you require multiple data sets to be maintained synchronously at all times. And then, of course, what use is there to finding these data issues if you don't actually take the step to fix them or improve its quality? You can write rules to automatically correct and enhance your data in such a way that the next time you run it through the same baseline data validation rules, they'll end up conforming to the data quality standard that you set. So I think one of the key things in implementing these steps is to make sure that the rules that make up these workflows are kept in a somewhat controlled environment. You don't need 100 rule authors editing these rules. In other words, you wouldn't want to have too many cooks in the kitchen. Especially if I'm a data contributor, I don't necessarily need to be involved in learning how to write these rules in 1Integrate in the first place. Here's our solution for that. 1Data Gateway is a self-service web portal that has a 1Integrate rules engine under the hood. It offers a controlled way to share validation and enhancement workflows between internal and external users. So let's go through a quick animation here to demonstrate how a state might be able to use 1Data Gateway as a submission portal for its various data contributors. So to facilitate data contributors' data submission, the state can host the 1Integrate rules on your server. The contributors can then upload their data to 1Data Gateway, where it goes through a series of data validation rules. If there are issues found, contributors can download those results, giving them the opportunity to address those issues, particularly ones that might not have been set up to automatically be fixed within the rules workflow, or those that might require some manual review. Once they've cleaned their data, contributors can resubmit that to 1Data Gateway. If the quality is at 100% conformance to those rules, 1Data Gateway can also be set up to deliver that clean data to the state automatically. So as you can imagine, an automated data supply chain that's been set up this way can be applied towards so many other data management needs. For example, we do have customers that use 1Data Gateway to enforce data governance for NG 911, such as the states of Maryland and Michigan. Now how about we see 1Integrate and 1Data Gateway in action using our LA County datasets. Just a bit of background on LA County. They were running into a lot of issues with their addressing data, and with data that's representing a population that's large enough to be the 7th largest if it were a state. Manually combing through and looking for inconsistencies between their address points, their roads, their buildings, as well as their parcels would be next to impossible. So what we're going to do is validate a sample of their Countywide Address Management System, or CAMS data, and see how we can best coordinate any mismatches between them based on their spatial and attribute relationships. So we are going to submit a sample of our West Hollywood data, have them run against some standard data validation rules, as well as automated data cleanup workflow. Just to give you a glimpse of how that data looks like, I have West Hollywood here, pulled up from ArcGIS Pro, but you can absolutely use any GIS application that you have on hand. So some of the validation rules that we want to run for this data is dependent on this expectation here, where a spatial relationship implies an attribute relationship. To check that this expectation, along with other quality standards, hold true, we wrote multiple sets of these kinds of validation rules. So let's go ahead and submit this data to 1Data Gateway on behalf of West Hollywood. 1Data Gateway is available in the cloud or on-premise, so let's just say for this instance that this 1Data Gateway is sitting on LA County server. So let's go ahead and log in as an authorized LA County data provider, and we should be able to see which projects I'm allowed to make a submission for. Let's look for the one for West Hollywood. Let's go ahead and select our valid and clean addressing data workflow, start a submission by simply clicking and dragging our West Hollywood data in here as a jurisdiction input submission. The engine is now going to try to read the schema of the entire data set that we just submitted and trying to map that to the actual schema that the rules have been set up with. If it's able to do so successfully, we should see that it is a success. If not, we are going to be asked to review them. So it looks like it was a success, but what if it hadn't been? Let's go ahead and review the mapping here real quick. So this is where we can manage our schema mapping. This is where we can customize how each class and how each attribute actually gets mapped across and submitted in this workflow. This step really allows for multiple contributors who use very different schemas to submit their data to be run against the same set of validation rules. That way, you only really need to write a single set of rules for every single contributor. Now, if we had made any changes, we can save them here, so you can also skip this step next time, but we're going to go ahead and hit continue and kick off the processing session. A session is just a term that we use to refer to a list of tasks to make up a workflow within one data gateway. I also mentioned earlier that 1Integrate, again, is the rules engine running under the hood. We are going to take a look at that in a little bit as well. A session always has to start by reading our data in, and once that's loaded, we are going to push that through a series of validation rules. Again, these are rules that we are requiring our data to conform to. So the first set of rules that we have here are what we call the essential geometry checks. These are meant to find the very common geometric issues we usually have in our GIS data. We are looking for kickbacks, spikes, duplicate points, duplicate features, etc. And we also have some road checks in here, just some additional geometry for road rules to make sure that our road network is well connected. It also contains some very basic attribute checks, such as checking that all of our roads actually have names. We have some inner feature checks under our address point tab here, and what this will do is help us verify their positional accuracy. One of them is checking that if address point is inside a building footprint and or parcel, then their address information in their attribute table should match up as well. Other examples of addressing related rules are on this addressing check here. We are checking that in relation to how a road that's been digitized, there should be no gaps, no overlaps, or parity switches between these address range values. Next, we have some rules nested under here that would actually modify our data. We are going to smooth out any of the kickbacks and spikes that we found. Our build topology process in here should also address our topology alignment issues, taking care of those overshoots and undershoots, for example. And if we find any address points outside of our buildings, we want to check for possible building locations within certain parameters, such as a distance and some similar address information that's available. We're seeing here that once a rule has finished running, we should be able to see these instance results, such as our conformance rate. This indicates the percentage of the data that conformed to the rule. So if it's not 100% conformance, it means we have non-conformances in the data. So we're seeing that we do have non-conformances in here for duplicate features. We did find kickbacks, we found some spikes as well. As we go down this workflow here, you're going to see that I actually reran some of these rules. And the reason behind this is because this allows us to check that the automated fixes actually worked without having to export that data and look through it manually. We can do a quick before and after comparison right here. So we should be able to see that we are able to smooth out, ideally, all of our kickbacks and spikes. We also should have some remaining nonconformances, and what we're going to do is to check on those. There's a last task in here at the bottom of that workflow to export our clean data, as well as a markup layer that can actually drive us to the location of our data issues. Now we should see that this processing time in here should be approximately 3 minutes, and I just want to mention that the reason behind this performance is all about the rules engine. The 1Integrate rules engine, operating again under the hood, has a spatially optimized object-oriented disk cache. That means that as the data is loaded in, it is automatically indexed. The performance here is not compromised even as I increase the complexity of my rules. Performance here is definitely scalable. So let's look here at the bottom. Let's see if it's finished. We are going to go ahead and hit continue because I do want to show you some things in here where we can download our results. Right here is where we can download a copy of the output data that we have just produced. What's nice here is we also have an auto-generated PDF report in here, particularly useful for people who need to keep metrics on their records. This should show us the entire one that we just did, again for West Hollywood, kind of giving us a nutritional facts on the data that, again, we just submitted. So it's definitely nice to have this on file if that's something that needs to be maintained on your end. So now that we've downloaded the data, let's go ahead and look at those results back on ArcGIS Pro. Let's take a look at our pre-marked bookmarks in here. So let me bring up our markups first. In here, again, it should drive us to a location of each and every single one of these non-conformances. We have some of our address points, roads, buildings, as well as our parcels, and it tells us exactly which rule that particular object has actually failed in. So in here it says that we do have a kickback in here. So if we zoom in, we should be able to see that it actually dropped a pin on these vertices that are causing this kickback to occur along this road center line. It does the same for our spike, where we definitely do have to zoom in for this one. Again, dropping a location on that vertex causing that spike to occur. Let's also take a look at some overshoots and undershoots. Down here, we can clearly see that it is not snapped. If we zoom in here at the top here, we're also seeing an undershoot right here. So all we're saying is that within a certain distance, these three intersections should probably be snapped together. Let's look at one of our attribute checks in here. So in here, it says that we have a road center line that failed our rule checking on the zip code values. So what we're doing here is the way that this rule was written was in a positive language by saying that the zip codes have to be a positive integer between an expected range of valid West Hollywood zip codes. So what we're seeing here is for the street center line, our zip code right here is null. So we definitely encourage writing our rules in a positive language, and that's because it's way more efficient and simple of a check to write by stating what makes the data correct as opposed to listing out all the other possible things that would make it incorrect. Let's take a look at another nonconformance here for a road center line without an address point within address range. So in this rule, let me turn on our labels. All this rule says was that if we have a road center line that has valid address range values, within a certain distance, we should have at least one address point that belongs to it. So within this view, we are seeing some address points for Melrose. We're seeing some for Croft, Clinton as well, but we are not seeing one for Rangeley, which is this road center line right here. If we take a look at this attribution, Rangeley Street does have some address range values. So it doesn't mean that Rangeley Street is non-conformance. It's just one of those things that maybe we want to check and make sure that our road name should in fact be Rangeley Street. Let's take a look at another interfeature check in here. So for these rules, we were saying that we should only have one address point per parcel, and we're seeing that we definitely have multiple ones in here. If I select this real quick, our address points in here are for 412 Live Oak Wash. Our other address point is for North Sherbourne Drive. Our parcel does belong to 412 North Sherbourne Drive. So it looks like this is a non-conformance for the Live Oak Wash address point. Now let's take a look at our address points that don't have a building. So in here, we're seeing that we have a non-conformance in here for being outside of those buildings. If we actually zoom into this one on the upper left corner here, it is just really a few inches shy of being contained within that building footprint. Now, because we also exported our clean data, let's go ahead and bring that up. And let's take a look at what we're actually fixing in our data. Let's revisit our kickback. If I zoom in here, we should see that being smoothed out. Same goes for our spike. And let's double check our overshoots and undershoots as well. We're seeing that these are now aligned. One of the things that we did do here is we only automated fixes for where we were saying we were comfortable automatically fixing. I believe that the tolerance that I used here is 5 feet. So let's take a look at the difference in here. So this is under 5 feet, but we said only automate the fixes for distances 3 feet and below. Let's take a look at our address points outside our buildings. So in here, what we really want to look again in here is this one at the bottom right and this one on the upper left. So what you're seeing here is it looks like we did move this one right here. And for this one, it appears to have stayed in place. So one of the things that we did do here for our address points was to create these proposals. These are things that we want to use to help us visualize where we think our address points should go for them to conform to the rule. So in here, we are seeing a green one, and it actually applied our address point in here. Right here, we're seeing a red, which got rejected. And the reason behind that is because the way that the rule was written, we said only go ahead and apply those proposals if there's a one-to-one relationship between an address point and a building. Within this parcel, we actually have two candidates for this address point, even if it is closer to that one. So what we're doing here is saying don't auto-apply this. We should probably review it. Let's take a look at other reasons why a proposal might be rejected. In here, the reason why this address point has been rejected is because there's already an address point within that. So again, we're trying not to introduce more nonconformances as we're trying to auto-fix. As we improve our data, it will be helpful to put a visual on it. So I want to show you One Data Gateway's comprehensive dashboard that's available for us to view. Up here, we should see a dashboard, and what's nice about this is it gives us an idea of the top violated rules in my data, how many submissions am I doing per day, and as each time I submit, do I actually increase my conformance over time. We can also use this to run comparisons between an entire project. Let's take a look for one that we did for LA County. And in here it tells us the different jurisdictions that submitted, again, our top violated rules, and if our conformance is actually improving over time. I've mentioned earlier that this One Data Gateway portal has the OneIntegrate rules engine under the hood, so how about we go ahead and take a look at our OneIntegrate interface real quick. So this is the OneIntegrate Sessions tab, and again, a session is where we have a list of tasks that make up our workflow within OneIntegrate. This is the exact workflow that we just ran earlier, where we are checking all these rules after loading the data in. Let's take a look at one of these rules right here for address within building. And really what I want to show you here is when you're writing these rules, you can definitely use a database as a context to your rule writing. So we are going to go ahead and select a jurisdiction input for our data. And what this does is it lets us pick and choose which class we want within that data and which attribute we want to write a rule against. We are not hard coding anything in here, which is why we're able to assure, again, that our rules are compatible with the data we want to use it for. When we brought in this data as a context, we refer to it as a data source. Let's go ahead and take a look at that data store for jurisdiction input. What I want to show you here is, again, how OneIntegrate is actually data agnostic. We are not restricted to the usual SG-file-G database or SG shape. We can also bring in CAD files. We can bring in flat CSVs. We can connect to an SG Enterprise G database on a server, as well as some SQL, Oracle, and PostGIS. So I also mentioned earlier that you can definitely use more than one source of data for each workflow within OneIntegrate. So let's go ahead and take a look at a use case for that. I want to talk about how we apply data integration for Cuyahoga County. And what I really want to showcase here is, because the rules engine definitely offers more than just GIS to GIS data processing, I want to show you that we can read in multiple data stores in the same session, even if these data stores are in different formats. So one of the data issues that Cuyahoga County wanted to address was between two departments that are maintaining very different information, but for the same data type. So in this case, it's a tax parcel information from a computer-assisted mass appraisal or CAMA system and parcel boundary shape file sets maintained by their GIS department. By running these two data sets against the same set of business rules for parcel data, we are able to determine records with conflicting information, and we can also facilitate automated integration between these two sources. More importantly, we're able to identify records that are actually missing between the two. And I just want to mention that in the UK, we ran a very similar exercise with Northumbrian Water and United Utilities. They found out that there were actually hundreds of water clients that they were not billing. Another way to resolve data sets that are out of sync is by applying these change detection processes. So in the case of Collin County, Texas, every time they received updates from their local jurisdictions, they would pastry cut and replace the road data using city boundaries. What this process entailed was manually stitching the data back up along the edges. As you can imagine, they were spending a lot of time updating their data this way, and because they were cutting and pasting, you would also typically lose metadata and history as the process continues on. So blowing that data away and replacing it entirely does seem like an overkill solution, especially since for the most part you wouldn't really be expecting such dramatic changes on road networks rapidly. So they asked us to help them come up with a more efficient solution, which would be to deploy a change detection process instead. One integrate allows you to load in, again, multiple data sources in the same session, so we can actually pull in source data and submitted data together and run them against the same rules that help us determine how these two layers interact. Do the geometries stay the same? Are there differences in bearing? Do they have the same address information? So on and so forth. From there, we have rules that generate proposals on features where we do have changes. So in the same workflow, we can export those proposals out for manual review, or we can simply go ahead and push those for automatically being applied in those dataset. This is basically the same process that Census has implemented for their Tiger data versus their partner road data integration. Just to highlight once more the capabilities OneIntegrate and OneData Gateway can assist with the data management processes, we submitted data to test some validation rules against them and received instant feedback results. We can also deploy OneData Gateway submission portal to ensure that submitted data doesn't pollute the master data by only making sure that we deliver what meets the business rules that we have in place. And we can see how it can be leveraged to roll out updates to enhance your data and keep it current. So all of these steps definitely promote data interoperability, which is really the core of having effective data quality management processes. You want it to be an ongoing process of collaborative data sharing. So again, just bringing it back to what Brian was asking earlier, as long as you understand what you need and what the purpose of your data is, you'll be able to determine the standards by which they need to be maintained. You'll be able to determine the rules that need to be followed. Because only accurate data is useful data. And that's the end of my demo. Thanks for tuning in. Brian?
Thank you for your participation in GIS in the Rockies and our presentation. Please reach out to us directly if you have any questions or would like to schedule a call to discuss some of the items we covered in greater detail. We look forward to working with you. 1Spatial, your data smarter.